Hello, this is Eddie Prieto, and this is my extra credit video presentation on the lecture Cosmic Rays, Alien Invaders from Space. Basically, what this lecture was about were cosmic rays, and just to briefly give you a description of cosmic rays, they are high energy particles, mainly originating from outside of the solar system. What they do is they produce, as they come down into the atmosphere, they produce showers of secondary particles that penetrate and impact the Earth's atmosphere, and they sometimes even reach the Earth's surface. They are composed primarily of high energy protons and atomic nuclei. Scientists still don't know where they come from, so they are of mysterious origin. They were first discovered in 1936 by a scientist named Victor Hess, and he was awarded the Nobel Peace Prize in Physics for that year for this discovery. Some more facts about cosmic rays is I told you before they are a bunch of particles that make up of a ray, and the particles begin to interact at around 20,000 meters in the atmosphere, and because of they are so high up, they cause radiation. So higher radiation is caused at higher altitudes, which I will get to that later in the presentation. And they also create charged channels for lightning to occur. And these particles can have energy anywhere from 1 e to the 9 to 1 e to the 20 EVs. And those higher energy particles can have as much energy as about a baseball going 60 miles per hour. Just so that you know, like what kind of energy we're dealing with. Those lower energy particles, however, make it harder to trace them back to their origin. And the way that some observatories, the scientists detect the origins of the rays is that they have sensors on the ground of observatories, and in those observatories, they don't measure the actual rays directly, but they measure the particles that they break into. For example, they break into particles called neutrinos and also high energy photons. So the sensors detect for those small particles, and they space them out across an observatory. And since the rays fall in like a shower, as the particles break up, they can predict the path that the ray took, depending on where it fell, on where the particles fell. So why is it are cosmic rays of interest to me? Well, I wanted to know what effect do cosmic rays have on human life, like my everyday life. What effect does it have? And I actually found that it did have an impact on a couple ways. For example, as I mentioned earlier in the presentation, cosmic rays have an impact in radioactivity. They constitute of a fraction of the annual radiation exposure of humans on Earth, about 13% of the total background for the Earth's population. And also, as I mentioned, for higher altitudes, about that amount nearly triples in radiation and for high altitude cities compared to sea level cities. Another effect that they have on human life is radiocarbon dating. I'm sure you've heard of carbon dating. It's used. The cosmic rays ionize the nitrogen and the oxygen molecules in the atmosphere, which leads to a number of chemical reactions. And one of the reactions results in ozone depletion. And besides ozone depletion, they also cause unstable isotopes in the Earth's atmosphere, such as the carbon-14 isotope. And cosmic rays kept the level of carbon-14 in the atmosphere roughly constant for the past 100,000 years, until the beginning of nuclear weapons testing in the 50s. And so this was important in archaeology for carbon dating. And then another effect is their effect on electronics. It's actually very weird how cosmic rays have enough energy to alter the state of the elements in the electronic circuits. They cause many errors to occur, such as corrupted data in electronic memory, incorrect performance by CPUs, mainly soft errors with electronics. as I mentioned earlier, it also is a possible seed for lightning. Cosmic rays have been implicated in the triggering of electrical breakdown in lightning. It has been proposed that essentially all lightning is triggered through a relativistic process called runaway breakdown, and that is seeded by cosmic ray secondaries, the particles that they break into. So after the presentation ended, I became really interested to see more research on where they come from. Obviously, scientists still don't know where they came from, because that is the big mystery and why scientists like to study this, to try to figure it out. But I just wanted to see how close they were. And I found that in 2009, there was a paper by scientists at the Pierre Auger Observatory that showed ultra-high energy cosmic rays originating from a location in the sky very close to the radio galaxy Centaurus A. But when I kept on reading more about it, the scientists said that it was not proven anything, and it was more of a coincidence kind of, and that there was no correlation that was found between the incidence of gamma ray burst and cosmic rays. And that's the end of the presentation. Thanks for watching.